We're all about Wi-Fi these days, right? But the real backbone of the internet, the thing that makes it all work, it's still this, the humble network cable. We see them everywhere, but most of us have no idea just how much clever engineering is packed inside. Today, we're going to pull back the curtain and unravel its secrets. I mean, look at it. It seems pretty simple, right? Just a plastic tube with some wires. But don't let that fool you. This cable is an engineering marvel that makes your streaming, your gaming, and everything else you do online even possible. So what is actually happening inside this little plastic jacket?
Okay, so let's get into the secret life of these things. In our super wireless world, it's easy to think that physical cables are becoming obsolete, but actually, they're the foundation of everything. And ironically, they're often the first place your connection breaks down.
So why do most of these problems happen on your local network? Well, it really comes down to one word: volume. Think about it. Your home or office has dozens of these cables, and they're constantly being plugged in, unplugged, and moved around. All that physical stress makes them the #1 weak point in the entire system. All right, let's peek inside. If you were to cut one of these open, you wouldn't find just one single wire. Nope, you'd find 8 of them, and they're all organized into 4 twisted pairs. And that twist, well, it's not just there to keep things looking neat, it's the first secret to making these cables work so well. See, if you just ran those 8 wires parallel to each other, their electrical signals would start to bleed over and interfere with one another. It's kind of like trying to have a conversation in a really crowded, loud room. You can hear bits and pieces of everyone else's chat. In networking, this is called crosstalk, and it's a total data killer. The solution, though, is so simple but absolutely brilliant. By twisting the pairs of wires, the engineers design them so that the interference from one wire actually cancels out the interference from the other. This tiny, simple twist is the key that ensures your data arrives clean, clear, and intact. So that little twist is the foundation. Now let's see how this builds into the cable we all know and use, the Ethernet cable. Because believe it or not all of them are created equal, and the differences are really important for getting the internet speed you actually pay for. You've probably seen CAT printed on the side of a cable before. Well, that stands for category, and it's incredibly important. If you're using an old Cat3 cable, you're capped at a measly 10 megabits per second. But that Cat5e or Cat6 you probably have at home, that can handle a full gigabit. That's 100 times faster. The key takeaway here is simple. Using the wrong cable can literally choke your internet speed. But it's not just about the cable's physical design. The devices at each end, like your computer and your router, they also have to agree on a set of rules for how they're going to communicate. If they don't, you're in for a world of slowness. One of the most important concepts here is called duplex. Think of half duplex like a walkie-talkie. Only one person can talk at a time. Over. Full duplex, which is what we use today, is like a telephone call. Both people can talk and listen at the same time. This is possible because different pairs of those twisted wires are used for sending and receiving data. And here's where the trouble starts. If your computer is trying to have a phone call, it's set to full duplex, but your router is stuck in walkie-talkie mode, half duplex, they just can't communicate right. This mismatch won't kill the connection entirely, but oh my, it will make it painfully slow. It's a classic and super frustrating networking issue. On top of duplex, devices also have to negotiate their speed. Most of the time, the auto setting works perfectly. They just figure it out and agree on the fastest possible speed. But sometimes that auto negotiation can fail, forcing one end of the connection into a much slower speed and creating another nasty bottleneck. So we've covered the basics. But for the real network pros, there's a whole other layer of complexity. It turns out you can actually wire the ends of these cables in different ways for very specific jobs. This is your standard everyday Ethernet cable, the one you probably have a drawer full of. It's called straight through because the wire on pin 1 on one end connects to pin 1 on the other, pin 2 to pin 2, and so on. It's designed specifically to connect a device, like your PC, to a central network device, like a switch or a router. Okay, but what if you want to connect 2 PCs directly to each other, with no router in between? That's when you need this, a crossover cable. It cleverly swaps the transmit and receive wires, so pin 1 connects to 3 and pin 2 connects to 6. This little internal swap is what allows 2 similar devices to communicate directly. It's really a specialized tool for a very specific job, letting 2 devices talk without a hub or a switch acting as a middleman. Now, it's worth pointing out that a lot of modern devices can automatically detect if a crossover is needed, but for a network engineer, understanding this principle is still totally fundamental. Finally, we have the most specialized cable of them all, the rollover, or console cable. This one is a completely different animal. It reverses the pinout entirely. Pin 1 on one end connects to pin 8 on the other, 2 connects to 7, and so on. This is not for regular data transfer at all.
Honestly, this is the perfect analogy for it. The console cable is what network engineers use to plug directly into the command line of a router or switch for its initial setup or for an emergency recovery. It's the ultimate backstage pass for configuring the hardware from the ground up.
So there you have it. From a simple twist of wire to a backstage pass for engineers, the network cable is packed with clever design. As our demand for data absolutely explodes and Wi-Fi gets faster and faster, it raises a really interesting question. Will the raw speed and reliability of a physical wire always be essential to our connected world?